Applications of matrices. One of the important applications of matrices and determinant is solving a system of linear equations. System of linear equations arise as mathematical models of several phenomena occurring in biology, chemistry, commerce, economics, physics and engineering. For instance, analysis of circuit theory, analysis of input-output models and analysis of chemical reactions require solutions of system of linear equation.
Formation of a system of linear equations. This can be understood by formulating a mathematical model of a simple practical problem. Consider three persons A, B and C go to a supermarket to purchase same brands of rice and sugar. Person A buys 5 kilograms of rice and 3 kilograms of sugar and pays rupees 440. Person B buys 6 kilograms of rice and 2 kilograms sugar and he pays rupees 400. Person C buys 8 kilogram rice, 5 kilogram sugar and he pays 720. Let us formulate a mathematical model to compute the price per kilogram of rice and the price per kilogram of sugar. Let X be the price in rupees per kilogram of rice and let Y be the price in rupees per kilogram of sugar. We know that person A buys 5 kilograms of rice and 3 kilograms of sugar and he pays 440, so we have the equation 5x plus 3y is equal to 440. Similarly, by considering a person B and C, we have 6x plus 2y is equal to 400 and 8x plus 5y is equal to 720. In the above example, the values of x and y which satisfies one equation should also satisfy all the other equations. If such values of x and y exist, then they are said to form a solution for the system of linear equations.
System of linear equation in matrix form. A system of m linear equation in n unknowns is of the following form: a11 into x1 plus a12 into x2 plus a13 into x3 plus etc. plus a1n into xn is equal to b1. Continuing this, we get am1 into x1 plus am2 into x2 plus etc. plus amn into xn is equal to bm, where all the a11 up to amn are the coefficients of the x and all the b k's are constant. In the system of linear equation, all the constant b k's are equal to 0, then it is homogeneous system. If it is not equal to 0, it is non-homogeneous system. If there exists a value alpha 1, alpha 2, etc., alpha n for x1, x2, etc., xn respectively, which satisfy every equation of the given linear equation, then the ordered n tuple alpha 1, alpha 2, etc. alpha n is called a solution of the given system of linear equation.
Then the above system can be put in a matrix form as A. A is the m by n matrix formed by the coefficients of the unknowns x1, x2, etc. up to xn. And let X be the n by 1 order column matrix formed by the unknowns x1, x2, etc. xn. Let B be the m by 1 ordered column matrix formed by the right hand side constants b1, B2, B3, etc. Bn. Then we have the following matrix form: Ax is equal to B. When the matrix B, the constant matrix B, augmented with the matrix A, then we can say the matrix A augmented with B. Solution to a system of linear equation. The meaning of solution can be understood by considering the following cases. Case 1. Consider the system of linear equations: 2x minus y is equal to 5, x plus 3y is equal to 6. Then when we solve these equations, we get x is equal to 3 and y is equal to 1. Both equations 1 and 2 are satisfied by these values. Is a solution of 1 is also solution of 2. Then we say that the system is consistent and has unique solution. The point 3, 1 is the point of intersection of the two lines observed by the following figure 1.2. Look at the graphs. The given lines are represented in a straight line, and clearly the point 3, 1 is the intersection of the lines, is a solution of the equations. Case 2. Consider the system of linear equations: 3x plus 2y is equal to 5 and 6x plus 4y is equal to 10. Solving these equations, we get 0 is equal to 0. This contradiction result tells us equation 2 is an elementary transformation of equation 1. By dividing equation 2 by 2, we get the equation 1. It is not possible to find the unique x and y with just a single equation. So we assume the value of one unknown, say y is equal to t, where t is a real number, then we can get the value of x. Then these two equations represents the one and only one straight line. In other words, the system is consistent and has infinitely many solutions, as t can assume any real value. Look at the graphs. The given two equations represents the one and only one straight line. Case 3. Consider the system of linear equations: 4x plus y is equal to 6 and 8x plus 2y is equal to 18. When we solve the equation, we get a 12 is equal to 18. This is a contradicting result, which informs us that equation 2 is inconsistent with the equation 1. So a solution of 1 is not a solution of 2. In other words, the system is inconsistent and has no solution. Look at the graphs. The given two equations represent two parallel straight lines. Note, interchanging of any two equations of a system of linear equations does not alter the solution of system. Replacing an equation of a system of linear equations by a non-zero constant multiple itself does not alter the solution of system. Replacing an equation of a system of linear equations by addition of itself with a non-zero multiple of any other equation of the system does not alter the solution of the system. Definition 1.8. The system of linear equation having at least one solution is said to be consistent. A system of linear equation having no solution is said to be inconsistent. Matrix inversion method. This method can be applied only when the coefficient matrix is a square matrix and non-singular. Consider the matrix equation Ax is equal to B, where A is a square matrix and non-singular, then A inverse exists. And A inverse into A is equal to A into A inverse is equal to I. Pre-multiplying by A inverse, then we can get the equation X is equal to A inverse into B. This is called the matrix inversion equation.